Okay, so if I were to check the suction diffuser screen on a hot water pump, the first thing I would do is I go over to the drive. Obviously right now number 1 is running, 2 is off, so I can turn 2 off. I would lock and tag it out. So I'm lock and tagged out. Then I can ultimately go into my pump. I can just close off the entering and leaving, cross it, hook my hose on the bottom of the suction diffuser drain, and I'll start draining water. The problem at that point, it's going to be airlocked, so I can remove the gauge, and on a higher, it doesn't matter, a higher port, you can just open it slightly and then allow the air to be vented in and allowing it to drain completely. It's the whole volute, so from this point down, it's all going to be drained. And then you would unbolt the flange on the front of the suction diffuser. There usually is an O-ring in there, be careful, or a flange gasket, and then you would just pull the screen out. And there might be like rocks or who knows, a little bit of debris in there. You just wash that screen off, put it back. Make sure you put it back in, you put it in the same manner where you took it out, because they can be skewed slightly, and you put the cover on and it smashes the screen. So you want to make sure you align it, and then you then again re-bolt it up. Once it's bolted back up, obviously you're still drained, the valves are still closed. So, and you can close your vent off, because you no longer need your vent. So both valves will be closed in that manner. Then you can open up the return, being that everything's closed, you can open up the return slightly, and the makeup water will make up the water that's, that's the void that's in here. And then ultimately you can have it open all the way. And then once it's open all the way, you don't want to open the discharge valve until you vent the remaining air out of it. So again, with the gauge still off, you can open up the valve slightly, crack it on either or independently, and then remove whatever residual air is in that piping. You're going to have a short amount of air in there, a limited amount of air in there that it'll be pulled out by the main air separator of the vent, so the automatic air vent. So once you bleed the air out, you put the gauge back on. Obviously, you can keep these valves closed, and at that point, you would open up your discharge. So open my discharge back up. My suction at that point would be already open. I'm all secure. There's no leaks. I come back over to my inverter. I turn it back on, and then I'm going to put it back into automatic. Okay. All right. So these are the ABB inverters. Right now, pump number 1 is running at 20 hertz. That's a minimum speed on this. There's about 300 lines of program that you can use the keypad to program it. You can read the manuals. There's a lot of program. A lot of the stuff we don't use. These drives are used for conveyor belts to go 2 different directions, then different types of torque. So these are variable torque drives, no different than on the Danfoss. But this particular drive, if I wanted to put it in hand and run it, I could actually just put it in hand, and I can, top right corner, I can increase the speed by just pushing the up arrow. Now I'm no longer in automatic control, so I have to recognize that I have a higher delta P going downstream because all the valves are closed. But I can run this pump in hand manually, okay, or I can turn it off completely. Now, obviously there's still power stored in the drive, but the inverter section's off. If I want to put this in bypass, like cross the line, right now it's in drive mode. If I push bypass section, it crosses over to bypass. If I want to push start, I push hand. It starts the pump in hand, but it's electronic bypass. It's not like you have a magnetic starter over there. Inherently, there's a contactor in there, but they call it Eclipse bypass. Inside the Eclipse bypass is probably another 30 or 40 program points, like overcurrent, under voltage, over voltage, those kinds of things that say, hey, look, if there's a problem, I can trip off. If I were to stop it, I just push stop, it turns it off. It has a feature in here, it says automatic, and you can push it automatic. And what auto bypass is, if the drive fails, when it's in operation and it's a hard ground or some kind of failure in the inverter, it'll automatically switch to bypass. I don't normally like to set things up for automatic bypass unless it's a stairwell fan for a high-rise building for ventilating a stairwell shaft for someone to breathe that's relieving the building if it's on fire. Any critical fan that you want to have cross the line start after the fact, you could use this feature. But in this application, it's not applicable. So if there's a problem with the drive, you can come over and you can command it to hand yourself. That way, at least you come up here, if the pump's failed, you'll know it on the automation. You can come up here and you can recognize what's happening. There's not water laying over the ground, something else that's wrong. Okay? So, again, to go back into drive mode, you just push drive. You'll see the drive light come on, which means now it's telling the drive to be the one that's controlling the pump motor. And then you would just push automatic. When you push automatic through the BMS, it'll restart. Is it a hard reset?
Sorry?
Oh, your VFD is a hard reset on failure? Okay. So once pump number 1 was online and running, and obviously we turned it off, so the automation is now saying, well, you were supposed to be running and now you turned off. Because it references, so would it auto restart?
Right now it's not demanding.
Okay, so right now we're not in demand anymore, so it turned off. So make sure that the auto in the top left corner says auto. If it does say hand, it's because you place it in the hand mode. It switches from hand to auto when you press the hand button. On the keypads displays, I program them so they're kind of user-friendly for you guys. The top one is the hertz, or basically speed from 0 to 60 hertz. These will be set from 20, because 20 hertz obviously gets the pump motor rotating. And then one thing we have to make sure is that there's a fan in the back of the motor, right, that keeps the windings cool. If we program them for 5 hertz, they'll run at 5 hertz, but over time the motor will get hot, because the fan in the back isn't running fast enough to ventilate the stator and the rotor, if you would. So 20 hertz keeps us up to where we can keep the motor cool. Then you have the amp draw, which is the current being drawn by the motor. And then the one below it, the reason why I customize it is that I put the voltage coming from the BMS on the screen. So if you're talking to the control contractor via phone and say, look, this pump's not running, I got it in automatic, it doesn't have a start command, or it's got a start command, but I don't see anything on the screen that says 0 volts DC. That means that the voltage signal he's setting to the drive is at 0, which means now it's at minimum speed at 20 hertz if it's commanded in at 0 volts. So I physically put the reference up here because when I work with these guys, I tell them with any kind of control contractor, give me 5 volts DC. If I have 5 volts and my spans from 0 to 60, my drive should be at 30 hertz. So it's a good tool for me to use, plus it's good for them to see what the reference is. So that's going to be the reference that's coming from the automation system. So if I have 10 volts, it's going to be 60 hertz. If you had to use the BMS to check it to make sure that the output is commanded, in here there's actually a little switch on the side of the face of the relay. This is a manual override.
Oh, cool. We'll just call him though.
Or just call him.